Heat. You will remember that we described thermal energy in stage 7. Thermal energy can be transferred between objects. Thermal energy can be stored in an object, but the thermal energy that is stored will eventually dissipate into the surroundings. Thermal energy is measured in joules. When the thermal energy of an object increases, the particles in the object start to vibrate faster. The energy of the particles increases. Heat is a measure of the energy in the particles. Heat is the total thermal energy of the vibrating particles in an object. The volume of water is the same in both glasses. One has a higher temperature than the other, meaning that the thermal energy, heat, is greater. The water at the higher temperature contains particles that are moving faster. The number of particles in both glasses of water is the same, but the total thermal energy, heat, of the particles in the water with the higher temperature is more. The water in both glasses is at the same temperature. There is a larger volume of water in one glass, so it has more particles. As there are more particles, the total thermal energy, heat, of all these particles is greater than in the water with fewer particles. That means the larger volume of water has greater total thermal energy, heat, than the smaller volume, even when their temperatures are the same. Temperature is not the same as heat. Temperature gives us information about two things: the direction that thermal energy will be transferred, the average energy of the particles in an object. The ice cream in the picture is at a lower temperature than the surroundings. The ice cream has been taken from a freezer at 20 degrees Celsius. The air in the room is at 24 degrees Celsius, which is a temperature difference of 44 degrees, from 20 degrees to 24 degrees. Thermal energy is transferred from the air to the ice cream because of this temperature difference. The larger a temperature difference between two objects, the faster the thermal energy transfer. Temperature also gives us information about the energy of the particles. Heat tells us about the total energy of the particles. Temperature tells us the average energy of the particles. This means temperature is a good way of comparing the particle energy between objects of different size or made from different materials. The soup and the water in the picture are made from different materials, so the types of particles are different. The mass and volume of the soup and the water are also different, so the numbers of particles are different. When we say the temperature of the soup is higher than the temperature of the water, we mean the average energy of the soup particles is higher than the average energy of the water particles. Another way to think of this is that 100 particles in the soup have more energy than 100 particles in the water. A sparkler is a small handheld firework. When you hold a sparkler, some of the sparks may fall on your hand. The sparkler can be at a temperature of about 1000 degrees Celsius, but one spark does not cause serious burns. Why not? The reason is the mass of the spark is very small, and the temperature difference between the air and the spark is very large. As there are fewer particles in the spark than in the main part of the sparkler, the total particle energy is much smaller. Therefore, the total thermal energy or heat of the spark is very small. As the temperature of an object decreases, the particles move more slowly. A scientist called Kelvin in the 1800s predicted that particles would eventually stop moving if the temperature is low enough. Kelvin also predicted that if particles stop moving, this would be the lowest possible temperature. Kelvin called this temperature absolute cold. We now call this temperature absolute zero. Absolute zero is 273 degrees. It is not actually possible to make particles stop moving completely, but scientists have created temperatures within billionths of a degree of absolute zero in laboratories. Remember, heat is the total thermal energy in an object, which is the total energy of all the particles. Temperature is the average energy of the particles in an object.